You cannot parallel conductors of different sizes directly from the same meter. The fundamental reason for this restriction lies in the principles of current distribution within parallel circuits and the potential for overloading smaller conductors. When conductors are parallel, the current divides between them inversely proportional to their resistance. Smaller conductors have higher resistance per unit length than larger conductors. Consequently, in a scenario where 3 1/0 wires are paralleled with 3 3/0 wires, a disproportionately larger share of the total current will flow through the larger 3/0 conductors due to their lower resistance. This uneven current distribution has several significant consequences. Firstly, the smaller 1/0 conductors could potentially be overloaded, even if the total current drawn by the load is within the combined ampacity of all the parallel conductors. Overloading can lead to excessive heat generation, insulation degradation, and ultimately a fire hazard. Secondly, the unbalanced current flow can negatively impact the accuracy and functionality of the meter. Electrical meters are designed to measure the total current flowing through the service. If the current is not evenly distributed, the meter may not accurately reflect the actual energy consumption, leading to billing discrepancies or, in severe cases, meter damage. The correct method for connecting different size conductors from a single meter involves the use of a gutter tap, also known as a junction box or a wireway. The gutter tap serves as a central point for making connections and distributing current. Here's a step-by-step explanation of the process. Firstly, the main service conductors from the meter are brought into the gutter tap. These conductors must be sized appropriately for the total load and must comply with all applicable electrical codes and standards. Secondly, within the gutter tap, the main service conductors are connected to appropriately sized tap conductors. These tap conductors will then feed the individual loads. The size of each tap conductor is determined by the specific load it will serve, following the guidelines outlined in the National Electrical Code or NEC. Thirdly, it's crucial to ensure that all connections within the gutter tap are made using approved methods and materials. This includes using appropriately sized connectors, applying proper torque to the connections, and providing adequate insulation. Fourthly, the gutter tap itself must be sized appropriately to accommodate all the conductors and connections. The NEC provides guidelines for determining the minimum size of junction boxes and wireways based on the number and size of conductors. Fifthly, grounding and bonding within the gutter tap are essential for safety. All metallic components of the gutter tap must be properly grounded and bonded to ensure a low impedance path for fault current. This helps to minimize the risk of electrical shock and equipment damage. The NEC provides detailed requirements for grounding and bonding electrical systems. Using a gutter tap provides a safe and code-compliant way to distribute power to multiple loads using different size conductors. It ensures that each conductor is properly sized for the load it serves, preventing overloading and minimizing the risk of electrical hazards. Additionally, it maintains the integrity of the metering system by ensuring balanced current flow. Now let's delve deeper into the NEC requirements related to paralleling conductors and using gutter taps. NEC Section 310.10 H covers the requirements for paralleling conductors. It specifies that conductors size 1/0 and larger can be paralleled, provided that they meet certain conditions. Firstly, all parallel conductors must be of the same material, for example, all copper or all aluminum. Secondly, they must be the same size and circular mill area. Thirdly, they must have the same insulation type. Fourthly, they must be terminated in the same manner. Fifthly, they must have the same length. These requirements are intended to ensure that the current is evenly distributed among the parallel conductors and that no single conductor is overloaded. NEC Section 314 covers the requirements for junction boxes, pull boxes, and handhole enclosures, which are relevant to gutter taps. It specifies the minimum size requirements for these enclosures based on the number and size of conductors. It also covers requirements for the installation and support of these enclosures. NEC Section 250 covers the requirements for grounding and bonding. It specifies the methods for grounding electrical systems and equipment to ensure a low impedance path for fault current. It also covers the requirements for bonding metallic components to create an electrically continuous system. It's important to consult the latest edition of the NEC and any applicable local codes to ensure that all electrical work complies with the relevant requirements. Improper electrical work can create safety hazards and may be subject to penalties. Let's also discuss some common misconceptions about paralleling conductors and using gutter taps. One common misconception is that it's acceptable to parallel conductors of different sizes as long as the total ampacity of the parallel conductors is sufficient for the load. As explained earlier, this is not correct because it can lead to overloading of the smaller conductors. Another misconception is that the gutter tap is only necessary when paralleling conductors. While gutter taps are often used in conjunction with paralleling conductors, they can also be used in other situations where multiple conductors need to be connected. For example, a gutter tap can be used to distribute power to multiple branch circuits from a single feeder. Another important consideration when working with electrical systems is safety. Always energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and eye protection. Follow safe work practices to minimize the risk of electrical shock and other hazards. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. Electricity can be dangerous if not handled properly. Furthermore, it is crucial to understand the purpose and function of each component within an electrical system to ensure safe and reliable operation. This includes understanding the role of overcurrent protection devices, such as circuit breakers and fuses, which are designed to protect circuits from overloads and short circuits. It also includes understanding the importance of proper wiring methods and techniques to minimize the risk of electrical faults. In addition to the NEC, other standards and guidelines may also be relevant to electrical installations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers or IEE and the National Fire Protection Association or NFPA. Consulting these standards can provide additional guidance on best practices for electrical design and installation. In summary, paralleling conductors of different sizes directly from a meter is not permitted due to the potential for unbalanced current flow and overloading of smaller conductors. The correct method involves using a gutter tap to distribute power to multiple loads using appropriately sized conductors. It's essential to comply with all applicable electrical codes and standards and to follow safe work practices to minimize the risk of electrical hazards. If you have any doubts or concerns about electrical work, it's always best to consult a qualified electrician. To reiterate, the use of different sized conductors in parallel directly from a meter is a violation of established electrical principles and codes. The primary concern is the uneven distribution of current due to differing conductor resistances. The smaller conductors will have a higher resistance, leading to a smaller proportion of the total current flowing through them, while the larger conductors will carry a disproportionately larger share. This can lead to overheating and premature failure of the smaller conductors, even if the overall current draw is within the combined ampacity of the conductors. The National Electrical Code or NEC specifically addresses the requirements for paralleling conductors to ensure safety and proper operation. Section 310.10 H of the NEC outlines the conditions under which conductors can be run in parallel. The NEC mandates that parallel conductors must be of the same material, same size, same insulation type, terminated in the same manner, and have the same length to ensure equal current sharing. These requirements aim to prevent overloading of individual conductors and maintain the integrity of the electrical system. The proper method for supplying power to multiple loads with different current requirements is to utilize a junction box, wireway, or gutter tap. This allows for the installation of appropriately sized conductors for each individual load, ensuring that each circuit is adequately protected and operates within its rated capacity. Within the junction box or gutter tap, the main service conductors from the meter are connected to individual branch circuits via appropriately sized tap conductors. The size of each tap conductor is determined by the specific load it will serve, following the guidelines outlined in the NEC. This approach ensures that each conductor is properly sized for the load it serves, preventing overloading and minimizing the risk of electrical hazards. Grounding and bonding are also critical aspects of electrical safety and must be properly implemented within the junction box or gutter tap. All metallic components must be properly grounded and bonded to ensure a low impedance path for fault current. This helps to minimize the risk of electrical shock and equipment damage. The NEC provides detailed requirements for grounding and bonding electrical systems, which must be followed to ensure safety. In addition to the NEC, other relevant standards and guidelines may include those from organizations such as the IEEE and the NFPA. These standards provide additional guidance on best practices for electrical design and installation. It is important to consult the latest editions of all applicable codes and standards to ensure compliance and safety. Common misconceptions regarding parallel conductors include the belief that it is acceptable to use different sized conductors as long as the combined ampacity is sufficient for the load. As explained earlier, this is not the case due to the uneven current distribution that results. Another misconception is that a gutter tap is only necessary when paralleling conductors. While gutter taps are commonly used in conjunction with paralleling conductors, they can also be used in other situations where multiple conductors need to be connected, such as distributing power to multiple branch circuits from a single feeder. It is crucial to always prioritize safety when working with electrical systems. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electrical work can be dangerous if not handled properly. In summary, the use of different sized conductors in parallel directly from a meter is a violation of established electrical principles and codes. The proper method involves using a gutter tap to distribute power to multiple loads using appropriately sized conductors. Always comply with all applicable electrical codes and standards, and follow safe work practices to minimize the risk of electrical hazards. If you have any doubts or concerns about electrical work, it is always best to consult a qualified electrician. Also, remember to make sure that all connections are properly torqued according to manufacturer specifications. Loose connections can create heat and lead to electrical fires. Use a calibrated torque wrench to ensure that all connections are properly tightened. Another important aspect of electrical safety is proper labeling. Clearly label all circuits and components to prevent confusion and ensure that the correct circuits are de-energized when performing maintenance or repairs. Use a permanent marker or labeling machine to create clear and legible labels. Regular inspections and maintenance are also essential for ensuring the safety and reliability of electrical systems. Inspect electrical panels, wiring, and components for signs of damage or deterioration. Replace any damage to worn components promptly. Perform regular testing of ground fault circuit interrupters or GFCIs and arc fault circuit interrupters or RFCIs to ensure that they are functioning properly. Keep electrical panels and equipment clean and free of debris. Dust and dirt can accumulate and cause overheating. If you are unsure about any aspect of electrical safety, consult a qualified electrician or electrical inspector. They can provide guidance and assistance to ensure that your electrical system is safe and code compliant. Never take shortcuts or compromise on safety when working with electricity. The consequences can be severe. Always follow established procedures and best practices to minimize the risk of electrical hazards. Education and training are also essential for electrical safety. Take courses and workshops to learn about electrical codes, safety practices, and troubleshooting techniques. Stay up to date on the latest advancements in electrical technology and safety. Share your knowledge and experience with others to promote a culture of safety. Electrical safety is a shared responsibility. By working together, we can create a safer environment for ourselves and others. To add more, when dealing with a 400 amp service, conductor selection is very important. Firstly, the service entrance conductors must be sized to carry the full load current of the service. Secondly, the conductors must be protected by an overcurrent device, such as a circuit breaker or fuse. Thirdly, the conductors must be installed in accordance with the NEC and any applicable local codes. Fourthly, the size of the conductors will depend on the ampacity rating of the conductors and the ambient temperature. Fifthly, the NEC provides tables that list the ampacity ratings of various types of conductors. Also, the conductors must be derated for ambient temperature and the number of conductors in a raceway. The service entrance conductors must be sized to carry at least 125% of the continuous load. For example, if the continuous load is 320 amps, the service entrance conductors must be sized to carry at least 400 amps. The overcurrent device must be sized to protect the service entrance conductors. The overcurrent device must not be larger than the ampacity rating of the conductors. The service entrance conductors must be installed in a raceway such as conduit or electrical metallic tubing. The raceway must be properly grounded and bonded. The service entrance conductors must be terminated in a panel board or other suitable enclosure. The terminations must be made in accordance with the manufacturer's instructions. Also, consider voltage drop when selecting service entrance conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC recommends that voltage drop not exceed 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law. The voltage drop is equal to the current multiplied by the resistance of the conductor. To minimize voltage drop, use larger conductors or shorten the length of the conductors. When working with a 400 amp service, it is important to follow all applicable codes and regulations. Improper installation can create a fire hazard or electrical shock hazard. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Another item to consider is the available fault current at the service. Available fault current is the amount of current that can flow during a short circuit. The available fault current must be determined before selecting overcurrent protection devices. The overcurrent protection devices must have a sufficient interrupting rating to interrupt the available fault current. The interrupting rating is the maximum amount of current that an overcurrent device can safely interrupt. If the available fault current exceeds the interrupting rating of the overcurrent device may fail to interrupt the fault current, which can result in a fire or explosion. The available fault current can be determined by contacting the local utility company. The utility company can provide information on the available fault current at the service entrance. The available fault current must be considered when selecting overcurrent protection devices to ensure that they have a sufficient interrupting rating. Another aspect of the service involves grounding electrode conductor sizing. The grounding electrode conductor connects the service equipment to the grounding electrode system. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrode conductor must be sized in accordance with the NEC Table 250.66. The size of the grounding electrode conductor depends on the size of the service entrance conductors. The grounding electrode conductor must be connected to the grounding electrode system in a manner that provides a low impedance path to ground. The grounding electrode conductor must be protected from physical damage. The grounding electrode system must be properly installed to ensure that it provides a low impedance path to ground. A properly installed grounding electrode system is essential for electrical safety. Additionally, surge protection should be implemented. Surge protection devices or SPD protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. SPD are installed at the service entrance and at individual pieces of equipment. SPD divert surge current to ground, protecting the equipment from damage. SPD are rated in terms of their surge current capacity. The surge current capacity is the maximum amount of current that the SPD can safely divert to ground. SPD should be selected based on the expected surge current levels. SPD should be installed in accordance with the manufacturer's instructions. SPD should be inspected regularly to ensure that they are functioning properly. Surge protection is an important part of electrical safety. Lastly, arc flash hazard analysis may be needed. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit in the air. Arc flash can cause severe burns, electrical shock, and even death. Arc flash hazard analysis is a process of evaluating the potential arc flash hazards in an electrical system. The arc flash hazard analysis determines the arc flash boundary, the incident energy, and the required personal protective equipment or PPE. The arc flash boundary is the distance from the arc flash source at which the incident energy is equal to 1.2 calories per square centimeter. The incident energy is the amount of energy that is released during an arc flash event. The required PPE is the clothing and equipment that must be worn to protect workers from the hazards of arc flash. Arc flash hazard analysis should be performed by a qualified electrical engineer. The results of the arc flash hazard analysis should be documented and made available to workers. Workers should be trained on the hazards of arc flash and the proper use of PPE. Arc flash protection is an important part of electrical safety.